2018. I'm now helping various companies in various capacities, consulting board membership. And it's a pleasure for me to be invited at the African Drone Forum to facilitate this session. So maybe we can jump right to the slide of the first session. So this breakout session will be divided in two parts. One part will be focused on operations with people experience with the terrain. I'm hoping that they will be able to give us a feel of how the technology is doing on the terrain and what are their successes and maybe also their frustrations, so that on the second part we will have drone makers talking about their products and their technologies and how they address said frustrations. I will have the speakers that you see come and present shortly. I will ask that if you have questions for the speakers, you hold on to them, you keep them in mind, and we'll keep them for a panel happen after those 6 speakers have presented. Once those speakers are done, they will sit here, wait for the other ones, and when the panel is complete, we'll have a discussion, and I'll be sure to give the mic to the floor so that you can ask your questions. So, without further ado, I will call to the floor, I will call Israel Bimpe. He's General Manager of Zipline. He's been instrumental in setting up their and running their operation here in Rwanda. Welcome.
Thank you so much, and good afternoon, everyone. I didn't prepare slides because I believe most of you will have the opportunity. You either visited Zipline before coming here, or you will probably visit over the weekend. And I encourage all of those of you who haven't planned to really make sure that you visit. But I'm also so sure you've heard and know about Zipline and what we do and what our work is about. Just one disclaimer, I'm not the Zipline General Manager. However, until mid last year, I was in charge of integrating Zipline into the healthcare system here in Rwanda, making sure we are also integrated into the aviation airspace regulation and everything. And now I'm moved on to a more global role position where I oversee how Zipline gets to build our services to be able to satisfy all the national and private healthcare companies that we get to work with when we expand our services, whether in Rwanda or in other countries. And today I just wanted, from an operation perspective, I really wanted to share some stories and learnings and what Zipline has been doing and what we've been learning so far. And it's pretty much covering 2 areas. One is on the operation side and the healthcare side, but the other is more on the core of flight operations and what we get to do. And when we started delivering, we started operating here in Rwanda in 2016. And in October 2016, we started delivering blood to few hospitals in the western part of the country. One of the things that we quickly learned when we do that is hospitals started relying on us. And we really completely transitioned the delivery of blood products from the national supply chain, trucks, buses, or anything that was doing it before, entirely to rely on Zipline. And it was an awakening moment because we started realizing that we not only have to build a strong and reliable drone technology, so the drone and all the systems that support it, but also we really had to build a strong and reliable kind of fulfillment service where we have nurses, pharmacists, and operators who can be able to build that side of things. And quick forward 2 years after, we started now delivering medical products. And when we moved into medical products, that's when we realized that there is a need to literally build a new part of the company, which what we call fulfillment as a service, which is now how do we go out there and integrate our services in private and public health systems. When we are working with the national health system in Rwanda, Zipline operates at scale. We deliver to dozens of hospitals from 2 distribution centers, north, south, and everywhere. So we really had to make sure that we nail the aspect of being able to integrate in a system that is already existing in the country and be able to not be a silo on the side, but more of something that adds value to the health system here. And so we kind of had to build a whole fulfillment system that integrates adequately in the information flow, in the money flow and products flow on how those kind of get to work and what that add to the operation. And that kind of realized that we are no longer a drone operator only, but we are more of a medical delivery service. And that means that we don't only, we are threading a very tough intersection of 2 highly regulated industries. One is healthcare and the other is aviation. And we really have, as much as we have to really have a strong reliability in terms of how we fly in the country, how we integrate with the aviation system, how doing hundreds of flights per day, but you also have to look on the other side of our warehouse. They have to follow all the pharmaceutical and health requirements, like being GMP certified and GDP certified and so on. The second thing that I wanted to talk about is when this type of operation gets ongoing, I don't know if anyone at Zipline was expecting, we had dreams really. We had dreams to make 100 deliveries a day. We had dreams to operate, dozens of planes at the same time. I remember at some point we were unable to build our system to be able to recover a plane and launch another one at the same time. And those were things that were so far. And then when all those started happening, that's when we realized that our system now has to be much stronger, and we have to build operation to really handle much more than what we currently do. And some examples that I will tell you is, how we try to work to continually adapt our technology and systems to the challenge of the operating environment. Not only running in operations, for those of you who visited that, you saw that our distribution center is pretty much an airport. To be able to input really rigorous processes, training mechanisms, SOPs, and everything. Some of them follow aviation standards, but some of them are also our own internal operation standards that we have to set. Because when you start being very dependable and reliable for the health facilities, you really have to make sure that your operation is fail-safe, is fault-safe, to be able to rely on that. And maybe a few examples that I will give you on what it is that we kind of did and how we've learned and what we've approached these different options. So I'll first start with high volume traffic management. Today we are able to have about 15, 16, 17 flights at the same time. So you have a hospital requesting an order, there is a mass casualty accident that's happened somewhere, and a particular hospital need, let's say, 20 units of blood. And for those, if each zip can carry about 4 or 5 units, then you have to send 5 or 6 of them. How do you build your system to be fail-safe enough to be able to handle such a high volume and traffic management system? And some of those things are, the technology part of things, which is, the drone, that's what they will talk about, but how do you build the GPS and communication system and so on, but also on the operation side of things, because we started realizing that a lot of human errors were causing operation to, go owl or something like that. And so we instituted, first of all, very rigorous standards of operation and how we do things, but then we also started doing an academy, pretty much a training institute and training facilities where all employees of Zipline who comes to join Zipline, they come in Rwanda and spend about 2 to 3 weeks ongoing a very rigorous training. No one ever passes that exams at the first go. And that rigorous training really ensures that everyone knows that to which levels that they have to hold themselves when it comes to safety and what it is that they do. And when you talk about high volume traffic management, you have also to look at how do you integrate within the airspace. And you have some protected airspace. You are, flying above cities, above schools, and there are helicopters also flying around. And how do you do that? Initially, what Zipline did is we really wanted to be part of the integration in the airspace. We we had to communicate with air traffic control to be able to get clearance whenever we have to fly, to maintain communication with the air traffic control if we have to return our flight, if we have to hold our flight in a zone, or if we have to terminate a flight in a certain area because there is an imminent collision or something like that. And some of those things also has to do with how we do our route planning and safety assessment. Zipline flies on pre-planned flight routes. We have some principles that we follow to be able to design the routes, and some of those, is either set by the Civil Aviation Authority, but others are also set for us to be able to respect our own internal reliability. And maybe the last point is on how to build reliable hardware for different weather and weather-averse areas. And usually, we couldn't know that some places in Rwanda have strong downdrafts, for example. And all we had to do is to be able to collect enough data from the flights that we're currently doing and be able to build a system that is really strong, reliable, and build the mechanism to be able to quickly change our routes and get them approved and establish that accompaniment and that ongoing collaboration with the regulators to be able to do that. I look forward to the questions and be able to answer more and speak on some specificity of our operations, but I just wanted to kind of speak on these brief areas of our operation and what we do in them. Thank you so much.
Thank you very much, Israel. So as I said, we will be taking questions for Israel and the other speakers during the panel discussion. So I now call to the stage Eric Rutayazayore from Charis, UAS. And please correct my pronunciation of your name if it's bad, which I'm sure it is.
Thank you very much. My name is Eric Rutayazayore, and I'm a founder and CEO of Charis UAS. It's a drone company. Thank you very much. That video sums up a little bit what Charis does all over Africa. And for my presentation, I wanted to talk about a use case, an innovative way we are using machine learning and drones in fighting against malaria. So I'm going to go through what exactly we're doing there. So we'll go over the problem statement, the current solution around that are out there, and the proposed solution that we have and that we've been conducting, especially in the cases of Rwanda. We use Rwanda as a specific use case in this case, and then a little bit of a conclusion to that. So recently, based on the data from the ministry, we've seen that there is an increase in malaria cases. And most of the time is because the mosquitoes have actually changed behavior, then started biting people even, outside, outdoors and during the day. Before it was mostly during the night. And so that case has really raised concern on how we can fight back. There was a point where Rwanda almost was declared malaria free, but in recent cases we have seen an increase, a tremendous increase. So these are the cases. I'm not sure if you can see it well. These are data for sometime in 2016. You could see, and in different parts of the country, how the issue has been, growing from the past years, and how it has been growing during these years. And obviously, in the latest years, it became a bit worse. So it's in that framework where Caris, as a company which really tried to use, to integrate drone and various systems to solve existing problems, that we felt like we can step in and do something about it. So there were many interventions around our country. There were indoor residual spraying, basically spraying in the houses, which is still going on. There were also long-lasting insecticide nets, which is also one part of the intervention that are happening, and obviously diagnostic and testing various malaria medicine. And the last part was larviciding and spatial spraying. And in that case, it was mostly a manual way people were doing that. And I'm going to single out the last part and talk about the current, drone-based intervention. We know all around the world there's a buzz about using drone in spraying, especially in wetlands or in rice fields, where they are mostly, mosquito breeding site. And most of these solutions talk about I would call it a major spraying over the field, the whole field. And we've done that as well, but we've found some limitation in that area and some, I would say, challenges that we faced, which I can explain. Sometimes you will find that you are missing breeding sites. It's not every small the water bodies that have the mosquitoes breeding site. So sometimes you will focus on the other and miss the other one. And with also the way the operation of drones are, you can easily, with the swath of the drone, you can easily miss in between the lines, places where there might be these breeding sites. So that was a major issue. And you can find as well in ditches and bushes, it's hard to find all the breeding sites. So there was also an inefficient use of chemicals. Because if you're spraying all over, you're going to use a lot of chemicals, and sometimes spraying in areas where you don't need to be spraying. And in that method, it's not really cost effective. If you have a very huge field, let's say in rice paddies, and you're trying to spray all over, then it's going to cost you a lot. And really, it wasn't practical in large scale sense. So we started looking at what are the ways we can actually use drone technology and other methods to really narrow down and only target those small breeding sites that obviously that has mosquitoes larvae there. So and is with this approach where we worked with various researchers and within as well the government of Rwanda, where we are using now machine learning and spatial algorithms plus drone in fighting these mosquito-based diseases, malaria, for example. And so this is a GIS-based approach. So basically what we're actually doing now, is we fly over first with various cameras and sensors, and where we start now taking various signatures of these breeding sites. They have various, at different stages. So we're able to collect data, understanding in various, let's say even in rice paddies, you have different levels of growth of crops in there. So we collect at all those stages and start developing models around that. And then we train the AI model to detect these breeding sites. And after we start, we collect all that, we feed the data into our algorithm, and now we start detecting all the breeding sites in the field. So far, we've been able to accomplish that at 95%. And we've done that, the testing in small areas where we are able to send even to do some ground truthing to making sure that our models is picking up the actual right breeding sites. And after we have all that in place, we send a drone to do targeted spraying in those areas. And this method is really efficient in a way we are just targeting the places where we have breeding sites, we have mosquito larvae, and we apply precise, amount of chemicals to just enough to eliminate those larva areas and breeding sites. So the benefits of it is also, we could see it's accurate, less usage of chemicals, cost-effective in a sense that if we want to scale up this intervention into bigger area, we can easily do that. And also it's a fast intervention, so it's really precise, and I believe it's going to be a new revolutionary way of targeting these diseases. And not only that, we can start training. We're working again with another organization where they have issues with different type of diseases as well, that we can use this technology. We can transfer this technology to them so that in that manner of targeting spraying, we can also use these models. So that was it for me. Thank you very much for the opportunity, and I will be looking forward to answer your questions. Thanks.
Thank you very much, Eric. I'm now calling to the stage Wilson Kagabo, CEO of Locus Dynamics.
Hello, good afternoon everybody. My name's Wilson Kagabo. I'm the Managing Director of Locus Dynamics. Locus Dynamics is a systems engineering and integration company, and we focus in the areas of aerospace, cybersecurity, and we also do homeland security solutions. I will try in this particular presentation to talk about how to basically adopt the technology, the drone technology, in the African context. How can we make it easy to adopt the drone technology in the African context? So I'll start with the journey that we've come through as a drone industry. You're familiar with this computer. This is where we came from. I found this online. It is a picture from 1952, Bell Labs, and this is how the computer looked like. This is how much we've come to in terms of computing power. It's very important to understand that for us as a technology, to be able to fit it into a drone we see today, there has been a lot of innovations happening in different fields, and I picked only 3 to highlight how that has influenced the drone technology and how that can now translate into the African context and be easily adopted and be used in a more better and expanded way than we're using it today. Okay. Camera. This is basically a presentation of payload. This is where we've come from as well. This is an aerial photography of 1918, and this picture doesn't do justice to compare, but you know the DJI ZX7, how small it is basically. Actually, the whole platform would be smaller than the camera you see to your left, I believe. Okay. This is the battery technology. These are the 3 technologies I wanted to compare. What we see here is that the benefits we see in high density, high power density batteries that are coming up, the lithium battery, polymer battery, the helium, or fuel cells in general that are also putting a lot of power into small batteries, is that the end result, the benefit, is in multiple times. We see that energy density increase compounded with a cost reduction will lead into the efficiency and adaptation. And that leads to more investment in manufacturing and more investment in R&D, and the cycle goes on and goes on. Now, these three technologies, or these three improvements, have led to significant reduction in the kind of platforms we want. The platforms, drone platforms, have become smaller, and now we're able to do many things with drones than we used to do in many years ago. So my topic now comes down. Now we know where we're coming from and how the technology has evolved. How can we leverage these innovations, or what other innovations can we do in order to make this technology accessible and usable on the African continent? We're using the technology already. Eric and Israel have already demonstrated what we do in Rwanda, but that's not the scale at which we want this technology to be used. I propose three kinds of innovations: engineering innovation, infrastructure innovation, supply chain innovations. If we want to see drones being used at larger scales in Africa, we ought to look into unique aspects on the African continent and consider those in engineering and design. We need to look at things such as launch, VTOLs versus catapults, and of course versus land. You talk about an infrastructure of runway to be able to do a mapping of a larger scale. Is that a technology that's going to work for us? Or a VTOL which can take off at any location and achieve the same mission? Altitude versus range. These are trade-offs that we have to do. In a country like Rwanda, altitude is very important. At any point you stand, he is probably 1.5 kilometers above sea level. You go to other places, you find it's very high. Our highest mountain is 4.5 kilometers. This is called the land of 1,000 hills. It's probably more than 1,000. I guess I stopped counting at 1,000. You ought to look into platforms and innovate platforms that are able to fly at high altitudes and be able to offer the kind of missions and advantages we want. Beauty versus cost effectiveness. I'm okay to buy a Ferrari, but if I've got enough money to buy a Ferrari and do other things. But if it's only for transportation, I'm okay as well to ride a bike. And that's the kind of comparison I'm talking about here. Being beautiful is good. Using very beautiful drones is nice looking, aerodynamically speaking, or ergonomically speaking, looking good is very nice. But in the end, it comes down, can it do the job? And at what cost am I willing to pay to do that job? On the African continent, that's a very big factor. C2 link, people who do drones, you know that data link is a very big factor. And a country like Rwanda, where you have 1,000 hills, every time you take off and you go BVLOS, your chances are there is a hill and more other hills in between, and therefore you have to overcome C2 link challenges. Innovations need to happen in that area. And another innovation that is very much needed is multi-purpose kind of drones. If you've watched the way we do things around here, is that if I have a car, it's probably the only car in the family, so we're going to use it for taking kids to school, for shopping and picking up stuff from the garden, and if I have to drop things there, I have to find a way to fit them, and also collect some building materials, and if they can fit, I'll fit. This kind of thinking has also to go into drones. The companies that do drone services in Africa, in one in particular, are small scale. They have little capex to start with. They want to have a workhorse, a drone that is able to swap payloads or swap usage and be able to perform more than just aerial mapping, but also do other. If it's doing spraying, can it also do something else that is not spraying? And that way my market size is much bigger. The point I'm trying to make here is that one size doesn't fit all. And this needs to be clearly understood in the engineering. Supply chain. Africa is perceived as a consumer market of drones, and I want to give you a challenge. Try to figure out or find one company on African continent making drones on a commercial scale. Try to get one to me and tell me this one is doing so. Why? Because everybody who sees Africa, they will say they will buy our drones. So manufacturers are coming in and say, can you buy drones? We have very fantastic. No one is saying, I want to open a manufacturing facility here to bring the drones and the spare parts and the maintenance and support closer to you. That's sort of not thought about. It's very difficult to move batteries around. I'm not going to labor much on this. I'm sure people who came here and probably those who are competing in the challenge, you understand that moving your batteries here was a big challenge. And the other one is spare parts that are very hard. Answer to this is make locally, make locally, make local. I cannot overemphasize that. Try to localize production of all this. And bottom line is that let the locals be in charge. Try to adopt the Toyota way of doing business, which is every time I go down the road within 5-kilometer radius, I'll probably find a mechanic who can fix my car or a spare part to replace mine. Business sustainability would depend on whether these guys in these pictures can do a part in the supply chain of drones industry. And if your answer is no, you gotta do better than that, train more and innovate more. Infrastructure that is common, that is able to deliver training, requirement, testing, fabrication, maintenance, innovation incubators, the concept of drone operation center, others they call drone ports. These concepts need to be implemented in Africa. They bring cost to do business very low. They bring a critical mass together, and they help us move forward in a better way. You've seen these pictures, these pictures, these pictures. They are all drone operation centers, concepts, and this one. With that, I end my presentation. Thank you.
Thank you very much, Wilson. I'm now calling to the stage Tom Verbruggen, who is CEO of iDroneAct.
Good afternoon. Very happy to be part of the ADF. I am the CEO and co-founder of iDroneAct, a software platform that makes it easy to fly drones in a safe, legal and efficient way. We've heard a lot of very useful use cases so far, flood control, malaria treatment, etc. But there is something before that useful application can happen. And I want to talk to you about Peter. Peter is a photographer. Peter could also be a scientist or an inspector. And he's also a drone pilot. And Peter needs help. And why does he need help? Because before he can bring the value that drones can bring, Peter needs to do about 20 to 30 tasks before he actually can start flying. He needs to check whether he can fly in a certain area. He needs to check the weather. He needs to check special pilot information. He needs to make a flight plan, and so on and so on. And often he does that on many different applications. And what if you're a big operator? What if you have many drones? What if you're a big company? Then those problems become multiplied because now you also need to manage your assets, train your pilots, schedule flights, and so on. The facts are that 9 out of 10 drone users are actually new to aviation. And aviation is the world that drones live in. What I've just shown you about Peter and big companies results in the fact that 80% of the time spent with drones, they're actually not flying. And in the flying is the value. So what we have built in 2015, we've built an all-in-one intuitive application that does all of that for the pilot. And we reverse the 80% into flying. We've got 48 features that we can group in three big categories. First of all, we make it safe to fly, we make it legal to fly, and we make it efficient. So we will see typically risk assessment, risk management, we will see real up-to-date aeronautical charts and UAV rules if they are in a certain country. We plan flights, we control them, and we even go so far as linking to authorities, linking to partners, and linking to manufacturers. Our mission is to clear the air so pilots can focus on their mission and fly more. Now, the benefits that Hydronect delivers are that we make it safe, legal, and efficient to fly drones, and that we also connect the different partners in the drone ecosystem. We will connect pilots to authorities. We will connect manufacturers to pilots. We are at this moment the most complete UAV management system. We don't call ourselves a UTM, but we integrate to a UTM. And our software can be used by individual pilots, enterprises, and authorities. Here they are, the people who can benefit from Hydronect are individual pilots, bigger groups, drone ports of which we just saw a few pictures, authorities, and drone schools. Our vision is that Hydronect, and the name that we chose actually has a little bit the connect in there. We want to connect the drone ecosystem. You see, all the players in the drone ecosystem can all connect to each other through Hydronect. And when I just said that if there are any drone rules, people can actually start following quite easily, intuitively. Of course, you need to get those drone rules inside the system. So we built a rule editor that transforms any complex drone rule into an intuitive flow. And as we are here at the African Drone Forum, there are 4 things that we developed specifically for this forum. First of all is our new user experience. We combine all of the tasks that the pilot needs to do on one graphical interface. So we would typically allow pilots to go and select the place where they're going to fly from. We're going to risk assess that flight by adding certain hazards. We're going to check the weather. We're going to allocate drones and pilots. And the system will then say if we're good to go to fly. And when that happens, we go fly. Second thing that we wanted to showcase at the ADF is our virtual control tower. Virtual control tower is very interesting because it can be used by local authorities or by country authorities to actually follow and track all of the drone flights that are happening on Hydronect. Even not only authorities, but big companies like big fleets with 30 drones or something can check what the drones are flying at the moment. Are they flying the intended flight? Third, what we want to show is the shortest way to drone value. The circle that you see there is in fact a continuous loop where the drone delivers the value. And what we do in that loop, we provide the automatic flight validation. So we prepare the flight and we check if a certain flight is good to go or not. And then the drone goes and flies, the mission flies and captures the data, and so on. And then as last, we're very proud, I will talk more about that tomorrow, but we're very proud of that we launched Hydronect East Africa, specifically to support the countries on the eastern part of the continent. I was Tom from Hydronect. I'm very happy to take your questions later.
Thank you, Tom. And we'll now call Andrea Blindenbacher to the stage. He's the head of training at Sunfly, and she has been for quite a few years already, and she's also the president of Drone Adventure, which is an organization focused on doing good with drones, and I think she will be talking about that.
Thank you very much, Antoine, for the introduction. Am I saying? Okay, perfect. So I'm Andrea, I'm president of Drone Adventures, an NGO that uses drones for good. We have been founded in 2013 upon doing some post-disaster mapping with the Sandfly EB in Haiti. Until now, we are a group of around 30 people where we consist of environmental engineers, aerospace engineers, drone pilots, surveyors, and GIS specialists. We have done up to around 41 missions around the globe and have mapped around 500 square kilometers within that time. Most of the time we're working with other NGOs or universities that are looking for doing special projects where they're just looking for the outputs to do special analysis. When we go on missions, we usually end up in very tough terrain. It's harsh, it's hard to get there. It's not easy to transport things. It can be hot, humid, cold, might be up high altitude. So we do need technology that can sustain all these conditions. On top of that, we also engage a lot with local community. So we try to build capacity. Ultimately, we want to do knowledge transfer, share our skills, and help the local community to potentially even use this technology themselves. So we need a robust, lightweight, and easy-to-use platform. Our most favorite at the moment is the Sandfly EB. It's a platform out of material that can very easily be repaired. It can be easily transported. It's up to 1.4 kilograms, if not less, depending on the generation of the EB. It can be carried on backpacks. It can be carried up mountains. If it does, and things do happen, gets a bit of damage, most of the time within 20 to 30 minutes, we're back up in air, being able to complete our missions. It's also very easy to learn. And eMotion, the flight planning software, is part of it, because the flight planning software has a simulator. So it lets you go into a classroom setting and you can show the students or whoever is interested how drones fly. It can be even in 3D. One understands how waypoint flying functions. One can simulate warnings and errors and how to react to them. But also how to plan a successful mission, because ultimately what you need, you want this to be a tool to give you the result with which you're going to work with. Outside, in the field, eMotion is still flexible enough and adapts very well to any situation, so any complex terrain is not a problem for this software, and will make sure that your EB flies safely and collects the data that you need to create these kind of outputs. This is a 3D mesh, could also be a point cloud or orthomosaic, and with this one could, for example, do an environmental study on that ice field that we see there, what happens with it over time. We go up there, we fly multiple times, we compare the data sets. This is an example from Lima, where it was about landslides assessment and the risk that these people have by living up on the slopes. So creating an orthomosaic, printing it, putting it on paper, showing it to the local community allows them to point out where they see problems, because they for sure have experience about the terrain, they have seen stuff happening. So spatial analysis happens automatically, and the first set of risk assessment can be done. Here another example from Tanzania, and we heard some stuff about this already this morning. So creating an orthomosaic, which is then used to digitize or create the vectorial maps, which can then be used for cadastre, can enable a community to prosper and a government to actually start organize things properly. Capacity building is our main goal, so we were big time involved in the Zanzibar mission. We were out there, we were on the start, we helped the people, we trained them up, we were there when drones broke down, we would help them repair them, we'd show them how to repair them, etc. So, and from this mission actually several other companies have evolved and created jobs for people, for more people around that area. Thank you for the opportunity.
Thank you very much, Andrea. And to close this first series of a speaker, I will call Alex Ntale, who is CEO of the Rwanda ICT Chamber.
Hi, good afternoon. Mine is not a presentation, but I want to welcome those our visitors who've come to Rwanda for the first time. As said, my name is Alex Ntale, and I'm the CEO of Rwanda ICT Chamber. Rwanda ICT Chamber is a member-based organization. We have over 300 members. These are technology companies, ICT and digital, that are, as you heard it yesterday, we have this mission or vision of building Rwanda into Africa's technology hub. And what we do at the Chamber is working with the companies, facilitating technology companies that are actually making that a reality. Already we have representatives that are here that have shown you their work. I'm here really to speak, just to talk about a little bit on what we do and how that connects, connects to what your company, your organization may be doing. We have five strategic pillars that drive our vision or our mission. And these driving digital innovation. With this, we work with young companies. They don't need to be or to have been started by young people, which although that tends to be the case on the continent for sheer reason that that's what the demographies actually indicate. And with these, we have innovation spaces, incubation hubs. Yesterday, you probably heard about the Fab Lab, K-Lab, and other co-working spaces, as Dr. Kamau demonstrated. There are hundreds of them across the continent. And through these, we've seen emergence of new innovations, new technologies. Some of these companies are actually leading on the market in terms of leading market share in the economy. And I need not point to some of those that are here on stage. And the second part is digital business competitiveness, where we work with companies on growing them. How do we facilitate a company that is existing in a market to grow their business, to grow their best, both quantitative as well as qualitative measures? Of course, on the qualitative, you're looking at skills, upskilling, but also making sure that you have the right talent with you. And as well as not just competitiveness locally, but as well as looking at what's out there and how that company can grow. Now, the third part is what probably concerns people that are in this room, which is digital transformation. And we're part of the Private Sector Federation, which has more than 75 associations, business sector associations. These are from agriculture to mining to real estate. And the use cases that have been presented here, most of them, when you look at them, they're not necessarily serving the technology sector per se, but rather they are either serving infrastructure challenges, they are serving the medical space, they are serving agriculture. And that's where participants that are here, that's where you come in. And what we have done recently in the 75 associations that we have in the Federation, we've started a drone and robotics association that to date has slightly over 10 companies that are in the sector, and including research labs. And what here to really talk to you about is just throw out a call for those companies that are coming in. Yesterday you had the minister allude to the fact that Rwanda is a proof of concept country. We have a testament here on stage from Zipline that kicked off the operations here. So what we have is an environment, an enabling environment that looks or seeks out companies that want to bring products, that want to bring new solutions to market, but at the same time, as Wilson mentioned, that understands local contexts and really is willing and wants to work with the local community. As the private sector, of course, as a government, they won't care what necessarily who. There's no restriction, so to speak. It's a liberal economy that you can work with. But we believe that B2B's collaborations that seek out win-to-win, win-win situations will actually help companies that are really at the forefront of the drone industry to grow and expand, not just in Rwanda but also in the continent. And with that, just want to focus which areas really. We had a lot about skills development. We still, every booth I've visited, I think I've had drone pilots mentioned every now and then. We have a challenge that our drones, we need to have skilled people on ground. So for companies that may be in that, we keen on most of the things that Wilson mentioned to look at the value chain. If you're building out a business or if you are trying to offer a solution, how do we build entire value chain in order to make this sustainable? Because one thing here and there, it just makes it overly expensive, and therefore you lose the competitiveness. So that's pretty much it. Research and development, universities, companies that are looking to do POCs. I'm here, I'm available to discuss and to help make connections that you may need. So thank you very much, and that's all I would say.
Thank you very much, Alex. So we have for ourselves 15-20 minutes to continue the discussion in more details. And for the benefit of promoting innovation, technological innovation and progress, I would like to focus my questions on what could work better in the operations as of today. Some of you have presented the successes. Usually we don't like to present the failures, but these are the things we use to progress. Maybe the first aspect I want to ask you about is software. I know for experience that software is a huge part of mounting a drone operation, be it for the actual monitoring of the drone, but we can talk about data processing, operational support, fleet management, supply chain integration, as Israel was mentioning. Even obtaining certification might require some software support. Yet we have many drone manufacturers talking about their physical platform and relatively few software providers. Thank you, Tom, for being there with us. What is your feeling about that? Do you find as operator that you are adequately supported by the available software, or you find yourself needing developing your own? Maybe Israel, do you want to start?
Sure, I'm happy to. I think Zipline's experience was when we started, when the founders thought of starting Zipline, they were doing off-the-shelf software and you know, trying to integrate it into the different devices that they were making at that point. But when you come to the point where you have to operate at national scale, you have to make several flights, you have to integrate the national airspace, and you have to provide a solution for air navigation services, what we know as UTM and so on. It kind of revealed that there was a need to, as much as we built the hardware part of the drone, we had to build the software part as well. And it's the whole system. It's not even the drone only. We use a catapult, we use a recovery system. We have a power system because hospitals rely on us for their patients. So that means that everything at the distribution center has to be perfect. And so that's why before even starting in Rwanda, we outsourced. We kind of brought back software inside the company, and it's such a huge part of the company itself. And that allows us, for example, to analyze the data in real time, because as soon as the drone returns and we put back the battery on the charger, we download all the data, and we can understand in real time what's happening and make sure you release the software updates that you need to continue operation, to make sure that you remain as dependable as the health facilities expect you to be. And that's like also being able to build an integrated software platform, right? When we are packing our medical products and scan the packages and the units, that information has to be transferred to the drone, and that has to be very seamless. And in Rwanda, for example, in particular, we don't only integrate the airspace, but we have different stakeholders who has to make sure that, like security organs, they have to know where we are at all times, and they have to have a view and direct access to what the plan is doing. So there is all those needs, and it kind of makes it really important that software becomes a huge component of the company, but equally big as the manufacturing is, as also the health operations is pretty much.
Of course. What's maybe Eric, on a smaller scales operation, what's your feel on the software? You had to develop your or co-develop your own image analysis software, for example. Do you find yourself often blocked by the lack of available software for drone operations?
Yeah, in general, there is a certain level of limitation, but it arrives when you start going into more specialized type of operation, because when you're just doing what everyone else is doing, and most of the time the software developers are looking at their market, like how much people they can fit into the same category. But when you start doing, for example, what you're doing in the malaria type of intervention, you find the need to start customizing or co-developing, as you say, or developing yourself certain software to help you address certain issues that you are facing. So in general, I think I would approach that question, the answer to that question would be of twofold, depending on really the type of complexity of the operation that you are doing. We find that there is a certain lack of the software side of it, but if you're just doing the general, then I think as of now there is a type of a more accessible, easily accessible software that you can use for general type of operation. And one thing I want to touch on is also the need of, as Wilson said, to customize it based on, let's say, Africa in context. Sometime earlier on we had a lot of issues when we're doing, for example, mapping. Sometimes the terrain following features. You have, for example, you will find that in certain part of Africa we don't have those data are not available there. So, and you are limited. So, and that's still a challenge as of now. So, I guess the manufacturers, I think they should also think not only on their platform but more on the software and where they're going to use it. If it's Africa, then there's a level of customization you need to think about as well.
Maybe Tom, you want to react on that, since you have announced something specifically for Africa?
Yeah, I think the answer is correct, that there should be like an evergreen solution to the problem that drones are facing, which is we want to maximize the opportunities that drones give us by then also minimizing the risks. And some operators or hardware providers, they will start building their own software because of the value that hardware provides. Yet the problematic of getting the value into the air would then need to be solved by a generic evergreen solution. And that is why I think when your question goes about why we go to Africa, is because I think that the speed at which drone value is being delivered in Africa at this moment is very high, and the support is needed at this stage, and that's why we do that.
In the spirit of producing locally, is the ICT, is the software and maybe redirecting existing software capabilities in other domain to the drone domain is something you're looking at the ICT chamber?
Yes, and I think when we talk about producing locally, we also need to look at the skill sets. What competitive skills do you have, or can you start with? And for Rwanda in particular, we've also clearly mapped out software buildings, capacities and skill sets along the software curve. That's where you have campuses or universities like Carnegie Mellon University that are set up here. Africa Institute of Mathematical Sciences that is here. You had a lot of work being done along lines of artificial intelligence, machine learning, and all these universities, the reason they've been attracted here, or the reason they've been invited here, is to see, as a landlocked country, how do we leverage the zeros and ones, because it's been, at least until now, it's been a little bit hard to get into the game that has hardware. That being said, we're beginning to see the hardware space also being democratized, in the sense that from computer-aided design, computer-aided manufacturing, small-side 3D printing, and CNC machines that are affordable, and materials that can quickly be shipped, or quickly shipped and brought to inland Africa. So that is also likely to change as digital continues to disrupt most of the traditional models of manufacturing.
Can I add something?
Sure.
I think just as he's talking, I just remembered another point, which is the necessity, the importance of the ecosystem when you are talking about software. I think there is a myth around the fact that it's all about making a machine know what to do, but it's more on the diversity of software skills as well that come in, or engineering skills in general. And that's something that Zipline learned the hard way. For example, the need to have a software or an engineer dedicated to weather issues, for example, or another one dedicated to, sense and avoid, and so on. So I just wanted to point out the need also of a variety and the ecosystem aspects that really has to come together in terms of being able to do that. Sometimes it can be within a company, sometimes it can be just outside the company, and built around that. And that's the importance of the initiatives like Kate just mentioned.
I think the multidisciplinary aspect, because the skill sets that you need to build software, or it could be drone or anything, that is needed for construction sites is different for agriculture, because you need someone who understands NDVI, what is it all about, and then someone else who understands what exactly infrastructure they're looking for in civil aviation, civil works.
Absolutely, absolutely. There's another topic I would like to address, maybe in the categories of the frustration, is the question of the cost and the profitability of drone operations. Have you, on the field, found yourselves, technology has a cost. Have you found yourself on the field thinking that maybe you would like a bit less technology because you don't really need it in order to optimize the cost of your operation? And generally, how do you feel all the current offering in terms of drone is addressing the question of profitability in operation in Africa, where capex are typically not as available as in Europe or the Western world?
I'm happy to start. I think we are the usual suspects when those kind of questions come up, so I'm not escaping it at this point. I talked about something earlier about us not identifying ourselves as a drone operator, but as a medical delivery service provider. And one of the things we really had to learn, and me specifically in my role at the company, is to really go out there, talk with government officials, talk with health systems leaders, and really understand like what is a real headache that you have. That don't think about a drone, just think about a solution that allows you to move a product from one place to another within less than 45 minutes. A solution that allows you to serve more than 300 locations from one single point. What pain point, what value, and what interest does that have for you? And then whatever the outcome that thing is, that value that it adds, can you put a cost to it? And that's where you start like thinking again, and backward you think about, it's not about selling the drone or the flight or the delivery, it's more about what is the value that's behind it. And that's something we learned as Zipline, where we look at, we are not only delivering a package from point A to point B, but what are the efficiencies that we are building in the health systems? What are the efficiencies that we're allowing a company that wants to be able to have much more visibility or direct access to their customers regardless of where they are? Like those kind of things. And usually that, from a business perspective, that ends up being a highly valuable thing that anyone is ready to be able to buy into and make a company like Zipline either really appealing to investors and really put us on a good path to profitability as a business as well. It's just about, less looking at the technology itself, but more looking at the value that you're providing. And you model your technology around that to be able to do that.
And also, I guess, the total cost of ownership of a system, including the maintenance and how long it's gonna last.
You want to go first? I was going to talk about the profitability. I think it's a function of at what the time you become profitable. Eventually, you become profitable, but you have to endure some days of drought. And it may take longer. Some of the things that we do at Low-Cost Dynamics is that we diversify our business offering, that we're not relying only on one specific service. So I told you we're a systems engineering and integration company. We're doing drone services. We're delivering systems. We're doing cybersecurity. So we have diversification. When one part of the business is not enough to sustain the business for a long term, we've got other areas that are sustaining the business, sustaining our path to growth, and eventually other areas that are doing slowly will catch up, and overall you'll be profitable. But if you just pick one area and say I'm a mapping company, and I'm looking at the market in Rwanda, and you want to get profitable in 1 year, the quick answer that is not political is no.
Maybe, Andrea, you want to react to that. You talked about capacity building in Zanzibar, for example. When those capacities are transferred to the local population, can they actually, with the business, access those drones, those materials that they need, or do they need further support? How does that happen?
Yeah, so far they definitely need further support. That's what I've seen a bit everywhere in the world, especially the poorer areas or where you transfer those skills. There's not necessarily enough money around to support these sort of westernized products if the manufacturers don't adapt pricing, for example, for certain regions, etc., or provide other solutions or other ways to help these clients become profitable quicker.
Eric, you wanted to add something on the cost of the systems?
Yeah.
And how it
Yeah,
affects
sure.
your
I think
operation?
my colleagues have answered most of it, and especially on the diversifying your services and all over. So, and that's what really Caris has done a lot, and not only locally, but trying to move in the region and beyond. Because on one area it's not enough to sustain the business, but also on the other side, obviously, the technology is, I would say, relatively new, and in the constant context of using it in our daily lives. So, the cost is still high in terms of even acquiring the equipment, to those who acquire the equipment, even the development. So one, I was really fascinated by some models that people are coming up with, a very interesting, innovative way of also structuring that cost. And some I've seen have started leasing, for example, which is a very, I believe, nice approach of helping those who want to acquire the technology start getting hands on that, and also trying to reduce the cost of operation. Because at the end of the day, if we don't reduce the cost, then there is, as Israel said, it will be very hard for the population, for the farmer to adopt the technology. So those are the things that we need to think about, and even more so in the context of Africa. Thanks.
Thank you very much. I think we will close this panel by taking a few questions from the audience, if there are any. There is one question, 2 questions. Any other question? So we'll quickly take those 2 questions and then let the panelists address them.
Hello, Thilo from Wingcopter. I have a question about the operation from Zipline. And you were mentioning that you're tracking flight data to improve the operation and the mission planning. Could you go a little bit more into detail, like what flights are interesting for you, how are you able to track them during the flight, and how does this affect your operation planning? Thank you.
Maybe you want to answer directly, Israel.
Yes, so if I understand your question well, you're asking about the flight data that we collect, what kind of data we collect, and how does that affect our operations, and how does that work? So the drone, as you probably have seen it if you visited us, is equipped with different data captures. We really want to understand what it is that the drone is encountering whenever it's flying. And it's everything, really, that it encounters, from wind speed, wind direction, how the drone is reacting and communicating itself in addressing different solutions, how the motors are reacting to a downdraft, or when it's landing to make a delivery, like everything, every single thing that happens to the drone from when it starts its flight from our distribution center to it lands. The way we do it, our drone are usually through the battery equipped with, kind of data loaders, if you'd say, that really collect that data. And as soon as we put back the battery, they will upload it on our servers, and in real time we can start analyzing. We also have a flagging system, for example. We know different categorizations of the data, so we can tell a flagging system of, this particular thing happened to the drone, someone should look into it. It was a nominal flight, no one needs to look into it. And that flagging system allows us to detect, for example, one motor wasn't really turning at the right rate, or the wind and something disturbed it. And that flagging system on different parts of the drones that we think are critical allow us to really know what to do about that. And the good thing about having an internal software team is that we can deploy either patches in terms of fixes overnight before we start operation again. We can halt operation for a few minutes to fix something that way, or we just deploy different software releases on a regular basis, on a weekly basis, on a monthly basis, depending on the need and what it is that we are addressing. But it also allows us, the most importantly, is to build the system and reinforce it on the go, right? So sometimes you need the basics, but over time you kind of figure out other things that you just push into the software. Like, for example, something as putting a reverse thrust on the motors, like allowing motors to turn in different directions, reduce speed while making a delivery. That's something you've already built the motor to do that, but the software probably kind of improves to adapt to those things. So it's a lot of things that happens there, and it's something that we do on the go pretty much. I hope that answers your question.
There was another question. Is the question still valid? There is one question there.
My name is Amos Pires. I want just to ask about security. So you see, someone can try to disturb your operations, like jamming your drones. So I wanted to know if you have started to think about that issue. Thank you.
I guess that question is open to everybody to answer. For us, I did talk about engineering innovation. That has to do with looking at securing your communication data link. Locus Dynamics, we're looking at different ways to do that. One is encryption for sure. Most drone data links are going to be encrypted. But we're also looking at frequency hooping as a way of avoiding jamming as well. But you're getting into more robust military-grade type of drones when you start talking about those kind of data communication security mechanisms. Not many commercial drones do have that, but we as a systems engineering company, yeah, we do take that as part of our design process.
Yeah, I would like that maybe to that, because that's of course a technical solution where you prevent jamming or anything. There is also a preventative method, of course, and that is trying to make it as easy as possible to fly in a legal way. And that is that as soon as all the drones that are flying around are the ones that can be monitored and be controlled, it singles out the ones that are not following the rules as such. So that would be a preventative measure.
Thank you very much. Well, in the interest of time, I think we'll leave it at this. Thank you again for your presentation. I think we can give you a round of applause. Unfortunately, I don't think that Rosa is scheduled for this one panel, so I'm sorry. And you can get to your seat. And without any further transition, I will ask Tom Plummer, the CEO of Wingcopter, to give the first talk of this second part.
Hello, everyone. My name is Tom. I'm one of the founders of Wingcopter. And despite all the technological advancements, still many people in the world are left behind. And many regions don't really have good infrastructure. So people really have no good access to medical care. Here, for example, in Vanuatu, we work with Dominic from UNICEF, who walks through this terrain to deliver life-saving medicals like vaccines for children. And he walks 7 hours. So that's basically the reason why we created Wingcopter. We wanted to solve these kinds of challenges, to really come up with a solution to deliver things more efficient, to improve supply chains, and also to save lives at the end by doing so. And as you could see, we created a technology where the core innovation is a so-called tilt-rotor mechanism. So you saw this drone taking off vertically, and then the rotors tilt 90 degrees. And when we created this prototype, already in 2012, we got lots of requests, more and more coming in. And so we decided, okay, we need to build it more proper. We stopped our studies. We were in our masters. Jonathan, for example, he studied engineering, lightweight aircraft, and aerodynamics. And we built one after the other and improved step by step our Wingcopter technology. So that was our first model. And by today, it's a very, very efficient drone. So what it can do, it can, first of all, be assembled very fast. So that's one thing we wanted. We wanted a quick solution, not something you assemble over months, or you need to really make like a big infrastructure around it. It's very easy. You just plug and play, basically. 5 minutes to set it up, 2 screws, and that's it. And then also the software. We work with, for example, here we work with Q Ground Controller, an open software, an open source software, and the rest is done basically by the drone. So the software algorithms of the flight controller is the Pix4, and then it just takes off. It does the transition on its own. The wingcopter can follow the waypoints, as you know it if you use drones, and then of course can upload the data as well via LTE communication directly while flying. So you can even have you can generate data and upload it. And it's also a very fast drone. As you can see here, this was a testing for our world speed records with Guinness records, where we were flying 240 kilometers per hour. But actually we wanted to create a solution, as I mentioned in the beginning. So since the payload is modular, we can use it, for example, here to give first information. That was with local authorities in Dubai, where we tested first response or first like sending data from an accident, as here a highway accident was tested. But it can be any critical situation, right? So the drone can fly out, send all the information directly, and then they can coordinate better. So that was like a multifunctional way to use a wingcopter. But at the end of the day, we wanted to really solve the logistics question. So how can we deliver things fast? And back in Vanuatu, what the example I brought up at the beginning, we were invited by the Ministry of Health and supported by UNICEF. And so we showcased that you can actually deliver on the same way like Dominic used to walk 7 hours. You can deliver in a few minutes the vaccines to the nurses on demand. And to do so, we created this lowering mechanism to actually drop the payload without landing, which saves time and brings down costs. So maybe a little bit about, because here's the tech talk, so a little bit about the technology behind this idea. Why we came up with this, we wanted by purpose not to land, because sometimes children are running around, we had to deliver to 19 villages. So on demand, so we didn't know which village would come up next with a stock out. So actually, for us, landing was no option, and also we wanted to bring costs down. So we had one station, and from one station with 2 people, we delivered to 19 villages, again, on demand. So the nurses really got used to it. We could prove that we can bring down the waiting time for patients, and unfortunately, after the funding finished, we had to come back, but we want to do this again. So we are looking for new funding, since the nurses really requested if we could keep up the service, and also the Ministry of Health would welcome anyone who would like to support this project to bring it back to Vanuatu. And it's also a biodegradable box. That was the idea, so you can drop it and leave it with the people. It's something very easy. You can transport it well, because it's made out of cardboard, so it's basically flat, and then you just fold it. And here, once again, the easy way how it works, and then the line cuts, so no one can pulse down the drone. And this was also important for us, that no one will, maybe by intention, tries to take down the drone, so the line is just cutting. The other thing what we did with DHL, we partnered up with DHL, we got some funding and support from the German government, BMZ and GIZ behind it, but also mainly DHL, and then we proved that we can deliver lab samples to the rooftop of a hospital, flying 65 kilometers, and then dropping the lab samples off, and they got analyzed fast. And then also on the way back to the island in Lake Victoria, so we worked at Lake Victoria for half a year, and we were flying back to the island delivering medicals which were needed. So from MSD to the island, like medical stores department to the island, and then on the way back to the hospital we delivered the lab samples. And lately we came to Europe, so we did the world first insulin delivery, which means we deliver together with a client and Vodafone. Vodafone actually helped to set up the LTE connection. So we were testing LTE communication, which worked perfectly. So we were flying 21 kilometers to an island in front of Ireland, and delivered safely these insulin medicals. And actually today I can, and that's basically the end of my, or the last point of my speech, I can say that if you have looked at TechCrunch yesterday, we announced that Wingcopter has done the first German BVLOS flight, roughly 30 kilometers from one factory facility to another one. We work with Merck in this project, and we got the waiver to fly above. We are crossing 2 highways, 2 railways, power lines, and even rivers. And yeah, we got the full BVLOS permission for this project, and this was a really big step for Wingcopter, of course, but also for Germany, because this is a real first BVLOS flight, I would say ever. I don't know if there's any other one before that, but that was a big step in Germany. So yeah, by saying this, I would welcome you, anyone here, if you want to do a BVLOS project, working with the Wingcopter, please come up. We would love to work more in Africa and in any other country in the world, since we are now ramping up production and looking forward to more projects and helping in the logistics and supply chain improvements. Thank you.
Thank you very much, Tom. I'm now calling Juan Hita, who is CEO of Venturi.
Okay, good afternoon, everybody. My name is Juan. I'm the CEO of Venturi, and I would like to give a talk about both technology and business perspective, as I think that it's very important for all of us. We talked a lot about medical delivery, so I also wanted to focus my presentation on the energy sector. I think that it's also very important to have access to energy for everyone, so it's not only medicines, but energy is an important matter. So this is an example of some remote area in Peru. It's production of oil and gas. And as you see, it's in the middle of nowhere, like very different and very difficult to access for maintenance. So if you look at this in terms of numbers, like there are a lot of anomalies per kilometer. This is a real example. So it's like 1,000 kilometers of pipelines, and each of them has like several anomalies every year. So imagine you are an integrity manager, and you receive for all of these anomalies one report like that. It's totally manual and like old school, no digital data. So in order to solve these problems, like first, the human risk of accessing these areas. Second, the cost, because the availability of helicopters in some of these remote areas is like, it's very, very expensive. And finally, as I said, having digital and automated data. So to do so, we started working on a VTOL aircraft 3 years ago. And yeah, we were thinking of how to operate from these remote areas, like you don't have any infrastructure. But at some point, we realized that there are more competitors out there, and we have seen like many VTOL manufacturers here. And to be honest, we reached to a point where you have like 100 kilometers range that you cannot use because there are no regulations for that. So having 110 kilometers, it's not our main purpose. And we started thinking, how can we meet the customers' demands, like how to do an end-to-end solution. And this is an example of power lines inspections. And we are talking about below 1 centimeter GSD. So it's a very challenging problem to solve. And that's where it comes, that we needed to develop our own gimbals, because there was nothing out of the shelf for that. And I challenge every manufacturer here to get this kind of data. That's why I think that we have to work on meeting these specific demands. This is another example of detection of hotspots in power lines. And finally, the LiDAR solution, which is for controlling the vegetation growth around power lines. And moving to oil and gas, we also can do mapping during the site development or integrity of pipelines. Another use case is security, like every couple of weeks, more or less, all oil and gas companies do inspections. And focusing on these specific demands of linear infrastructure, we detected that there are some issues coming with BVLOS that now most of the companies are not thinking about because it's not allowed. But in the future, since it's very difficult to have access to video links like from 50, 60, 70 kilometers, we are trying to automate everything that is possible that is not related to safety. So in this case, it's about controlling the power lines so that the sensors are auto-tracking the power lines and the poles. Okay? As I said, we have to build end-to-end solutions. We focus on the data acquisition, but we are partnering as well with both small and large companies that can provide the service and the reporting to the end customer. So basically, all these tenders are based in dollars per kilometer. So we thought that maybe it would make sense to move from the typical sales direct model to renting the system. So we partner with all of these drone operators so that we can provide the end-to-end solution for them. And so far, we already work with several corporates in the energy sector. As you can see, there are several, like from Spain, but also from Latin America and South Asia. And we also partner with some companies, as you can see, both large companies like Indra, but also small channel partners in Latin America. So to end up my presentation, I would like to introduce which we think that are the main partnership opportunities for us. First, if you're an energy company, we can do tests. It's not about the money, it's about validating your business needs. Second, connecting with contractors, as I said, both large companies and small drone operators that can deploy the solution in their country. And finally, the tech side. I think that it's also important that we can collaborate with detect and avoid companies, people that can make it easier for us to get the permits everywhere. So that's all, and thanks for the opportunity, and looking forward to answering your questions. Thank you very much.
Thank you, Juan. I'm now calling Sven Vlach, lead systems engineer at Phoenix Wing.
Okay, so hello everybody. My name is Sven Vlach. I'm the lead systems engineer from Phoenix Wings. And Phoenix Wings is a company that's very young. We are here since almost a little bit over a year. And we are based in Germany near Munich. Munich is a great aerospace hub where we have lots of companies that are known to many of you, like Airbus and the German Aerospace Center, M2 Aero Engines. And that's what we have chosen as our location to do our developments there. This is our system that we also brought here to LKC. It's a rather big plane. The Manta Ray has a wingspan of 3.5 meters. And very important for us, we can carry up to 10 kilogram payload. The maximum volume we can also carry inside is 32 liters, but we also have a bigger option with 40 liters. So some serious space to fit cargo or sensors. Our range with 5 kilogram payload is 54 kilometers. And we also have a longer endurance version where we can carry 10 kilogram payload over 100 kilometers range. So how do we develop our systems? Developing aircraft, as many of you know, is not an easy task. It's a highly interdisciplinary process. So we have very skilled people in all of these fields. And you combine in the development process the interaction between all these fields. Our ideas we then validate in a very high, very capable tool chain where we can check what we develop and simulate, and then if we are happy with the result, go out to our small test platforms. These small test platforms, we can really use them to do the aggressive stuff, test weird things, and when we are happy with this result, we move it out to our bigger platforms. We are very proud that we have the complete software that we use on our aircraft under our own development. So we don't use any of open source software. Every line of code that we fly is done by ourselves. A few examples. In the embedded side, we do, of course, a lot of C++, C development. We also use real-time Linux systems. We have very capable engineers in the area of sensor fusion and control algorithms. You will see something of that later. And on the ground segment side, we have also nice tools for simulating and controlling our flight. Here you see an example of our simulation test bed. That's the environment we use for testing, but will later also be used to train people. And that's already in everyday use in our office, since we do like virtual test flights before we go out to the field. Here you see one of our smaller test platforms. These are these test platforms, as I told you, where you can do very aggressive maneuvers with. And we use that, for example, to validate what we then later use as emergency capability to recover, for example, from a broken aileron or something like that. So if everything goes wrong or anything goes wrong, we just switch over to copter mode and we are very sure that this thing can recover itself. So what have we brought here to the LKC? You've seen us, maybe you can later see us down there. We have a really big drone. It's the Manta Ray. And I have some very current videos of this. This is us going out for the first BVLOS flight of the competition. And you can see, since we have all the software development in our house, we have good control over what we do. And as you can see, this transition is super smooth. And due to us having the software in-house, we can down the road, we will later have the capability to integrate even more cool stuff that you would be limited in if you have open source software, for example. You can see our craft coming in, and it descends really rapidly, -4 meters per second going down. That's an aggressive maneuver. We do that to save energy. We want to have the energy for long-range flight. And here you can see it touching down precisely on the pad. So with that, I would like to say, challenge us. We provide large cargo UAV solutions. So if you have anything that you can think about where a large cargo UAV might make sense for us, please meet us at our booth. And with that, I say thank you for listening. And, well, thank you for listening, and see us down there. We have many more videos to share with you. Thank you.
Thank you, Sven. The next speaker is Maximilian Layacker. He's a senior systems engineer at German Drones.
Yes, hello. I'm here to present a little bit more about our Songbird drone, and here in the context also of the Lake Kivu challenge, especially in the emergency delivery challenge that we participate. So we also have a VTOL, like many of you. It's also it's different to the one before. It's a tilt rotor design, so the tilt rotors has 4 of them. Has only 3 kilograms, like not 10 like we saw before. 3 meters wingspan, like 2 speed you see here, and then we also have like up to 100 kilometer range, and also 2 hours of flight time, and the advantage here is also that we have a really compact box, so we can transport it also just for with excess luggage on a normal commercial airplane. Here as we saw, like the challenge we thought about, can we participate with our drone without doing many changes, and we saw it really fits our drone. So we can, here the challenge was at least 1 kilogram transport to the island and back, and vertically land, and do this at this high altitude, and do it beyond line of sight, of course, because 20 kilometers is a pretty long time. So we saw, this is pretty good. We can just use the drone as we have it. It's already developed. We are selling it already, so it's be reliable. Then Also, we have some experience with BVLOS flights we've done in Austria and also Germany. Also, we did this last year, but not 30 kilometers like Wingcopter was planning to do. It was only like 1 kilometer in the one direction and the other direction, but over a railway where we did some inspection there. Also with permission and with unmanned traffic integration. Yeah, this was successful, and it was a different kind of payload. So, but when we looked a little bit closer here on the challenge, we realized that, like we heard before, that there are a lot of hills in Uganda, and especially one here next to the drone port on the beach, we have a hill that blocks the radio line of sight from the drone port to the island. So we had to think about a solution how to do that, and our ground station helps us with that. It's our own development. It can show you here what I highlighted, that on one part of the mission, of the planned mission, we would lose radio contact if we just place the antenna like next to the takeoff point. So we saw that, and the other part you can see we have terrain display on the ground station, which is here no problem because we're flying over flat water, so this won't be a problem for this mission here. So we had to think about how we are going to tackle this telemetry situation, because of course you want to have telemetry link while you're flying to see if everything is working out or react to other obstacles or other airplane traffic or so. So we decided, okay, we add a cell phone connection, which actually we already had for a different customer developed, and to have some redundancy, because we maybe couldn't rely, or the rules that should not rely purely on the cell phone network. We developed some relay stations that we can place on the island and on the hill next to the drone port to be sure to have line of sight to the drone all the way, even if something happened with the cell phone network. So that's a little bit complicated. Then we have different kinds of to be able to connect to the airplane, like of course then over the internet, but also if this fails, of course we have the relay stations that on the hill that are connected also to the internet, but also with a direct Wi-Fi link to the beach where we have the computer, and hopefully we'll always have connection. And we're looking forward to see this in action next week for the BVLOS flight. So internally looked, we have a embedded computer inside that does all the communication stuff, and then we have a custom piece of software that uses encryption for the telemetry, and also in case for other applications, also the video stream. It's in real-time downloaded thing. Yes, so we were able to do a flight last week for the demo, but I was not able to be there because of my plane not able to land here in time. So, but I could watch how it flies here in the hotel and check if everything is fine, and help my colleagues on the beach because I couldn't be there. And this is a little bit sped up, so we were able to fly out like 800 meters over the lake and see that I could live see plane circling around there. We had a small loss because internet is not always that reliable, but it was of course no problem. The plane could continue, and colleagues on the beach had direct link by the redundant radio. And then down you can also see some graphs, some safety features we have in our own developed ground station, which is it shows the battery voltage with the green line being what a known good battery should look like, and the orange line with the actual voltage also measured by the plane. So here we see that the battery is not perfectly on the line, but still an acceptable range. So that's really important safety feature by flying long distance to be able to assess how good is the battery, or if I have to do some maybe abort the mission, come back, or choose an alternative landing site. What we will be also provided here on this long-range mission with one island where we were able, if there's something, we see something is going on, we can emergency land there. And then we came back to the beach, did a landing back on the drone pod, and you could see that on the live video feed on YouTube. I don't have a video here in the presentation, but it's online. So to sum up, what we're going to plan for the competition is putting 2 kilograms of payload in it, running, having the whole total distance 38 kilometers, which should be no problem. And additionally, we have 2 safety pilots, one on the island and one on the beach, to like help if something happens during the landing, so to be safe. But we hope we don't need them, so we hope we have this completely automatic and controlled by me, the operator, on the beach over the internet. So, and we expect this only takes 40 minutes back and forth, the whole mission. So that's the picture of the demo flight with the external payload compartment, which we included with the setup for this transportation mission. That we have really a modular setup, which I showed you before. We have modular telemetry options, but also, of course, payload options that we can put inside, and in this case, also a little bit outside of the airplane. And then another example here on the left is a high-quality camera to do some mapping applications and remote sensing. And another application, payload, I want to focus on, and we spent a lot of time developing, is a real-time video stream with a gimbal camera. Yeah, and we integrated that in our ground station, so you can always see where the camera is looking at, and then have a live video feed and a joystick where you can adjust the zoom in and select a target to look at for safety and security applications. And here, in this case, we are in our van testing it like at 10 kilometers range with the live video stream, not over LTE this time, but a direct downlink. So we have also there different options to use, like the direct downlink, which has, of course, the advantage that you don't need external infrastructure. But it needs more power, and you need, of course, a frequency to use. Sometimes it's a little bit harder, you get interference. And you have, of course, limited range because you need to be antenna in line of sight. So, but of course we can also use LTE, like I told you before, where you can have almost unlimited range. It uses less power because optimized for mobile use, of course. But you have a higher latency as a drawback. So it's a little bit harder to track like moving targets when flying with drone, which is pretty fast in the air. So you always have to have a low latency link to it, but it is manageable. But of course you rely on external infrastructure. But you can combine both of these systems together in the airplane and have maybe somebody close by and then another person in a control station somewhere, like in another part of the world or another part of the country, which is very nice for security operations. So to close, we have a video. Should be a video, yeah. A nice shortened video of our drone flying and what do we provide? Oh, yeah. So we developed the drone in-house development. It's also the software we modified. It's based on the open source PX4, but we modified it, and the video is too big to play. Okay, that is an example of the high quality image. Yeah. Okay. That's why I wanted to test it. But yeah, example of we checked some sheeps, but they were innocent. There were no black sheeps in there. And of course, it has also a thermal camera. So yeah, thank you, and I'm happy then to answer questions later.
Thank you, Maximilian. Is Hanan in the room? It looks like we might have lost a speaker. So we will directly jump to the talk of Seijin Ho, who is Director of Research at FineVT, visiting us from South Korea.
안녕하십니까. 저는 한국에서 온 파인VT의 오세진이라고 합니다.
Hello, this is Se진ho, Director of the Research Center and FineVT Robotics, a Korean drone software company.
5G 네트워크를 이용한 다양한 산업 분야에 사용되는 드론에 대해서 말씀을 드리고자 합니다.
Today, I would like to talk about UAV application that can be applied to various industries using 5G networks.
우리는 다양한 사이즈, 다양한 센서를 운영하는 드론을 사용을 하고 있습니다.
We use drones of various size with various sensors.
우리가 간단히 사용되는 EOIR에서 SAR까지 다양하게 사용되는 걸 볼 수 있는데요.
Yeah, actually, I'm attached to a drone to a mini SAR recently, and actually, I'm using the drone.
우리는 흑백 영상에서 초분광 영상까지 다양한 영상을 처리를 하고 있습니다.
We use a variety sensor ranging from black and white to multispectral to hyperspectral.
저희는 그 V2를 사용을 하고 있는데요. V2는 멀티콥터 M600 모델의 12대와 같은 성능을 보이고 있습니다.
We are using fixed-wing water platform, which uses a battery that can fly 1 to 6 hours, has the capacity of 12 M600 multicopters.
고정익 비행기의 운영 조건은 화면에 보듯이 강한 바람이나 온도 차에 상관없이 운영할 수 있는 것이 장점입니다.
It's the same as the operating condition. You can see that you can check the screen of the fixed-wing airplane. It's long-lived, fast, and has large, which is make it efficient.
화면은 GCS 솔루션이 데이터 링크를 어떻게 사용되는지 보여주고 있습니다.
You can see at the screen just around communication.
실시간으로 처리되는 3D 영상은 화면처럼 드론에서 들어오는 신호를 5G 영상을 통해서 실시간으로 3D 매핑이나 영상 전송이 되는 것들을 볼 수 있습니다.
You can see at the real-time 3D big data system and widely used.
화면에 보는 것은 5G 통신망을 중앙에서 관제하는 모습입니다.
You can see that the screen, the 5G.
네, 중앙 센터. 센터 컨트롤 센터. 드론을 이용한 감시 정찰은 낮은 비용으로 높은 효율을 제공을 해주고 있습니다.
The sequence using drones provide high efficiency at low cost.
드론을 이용한 감시 정찰의 목표는 순찰, 비상 대응, 구조 등에 적용될 수 있습니다.
The objective of surveillance and drones using our patrols, emergency response, and rescue.
라이다를 이용한 초정밀 매핑에 대해서 소개를 하겠습니다.
Okay, let me introduce to ultra precise mapping using LiDAR.
라이다를 이용한 전력 점검 어플리케이션은 3차원 선로성 있게 선로 점검, 건설 등에 응용되어서 사용될 수 있습니다.
Power check application using LiDAR can be applied to 3D track design, track inspection, and construction too.
화면에 보이는 것은 라이다를 이용한 실제 작업 내용을 소개를 드리겠습니다. 현재 중국 남방전력공사의 1800km 구간을 실제로 점검을 하고 있습니다.
Let me introduce the actual rocking using LiDAR. China Southern Power Corporation is conducting a 1,800 kilometers power line inspection project now.
라이다를 이용한 것은 전력선뿐만 아니라 고속도로, 철도 등을 점검할 수도 있고요. 스마트 시티 같은 건설 부분에서도 응용이 가능합니다.
You can check at this screen highway, railroads, and next sector. Using LiDAR, you can apply construction like a smart city. Actually, here is a real example.
파인VT는 제휴유입사와 공동으로 UAV와 센서 그리고 처리 솔루션 등을 이용해서 한전 전력선 점검 사업, 원양어선 유인회기 교체 사업, 치안 및 사회 안전에 관련된 솔루션을 제공을 하고 있습니다.
In collaboration with JOUAV, FineBeauty is providing solution related to CAPCO power line inspection, ocean fishing vessel manned helicopter placement, and security and social safety using UAVs, sensors and processing solutions.
감시 정찰에서 제일 중요한 것이 무선 네트워크입니다. 전역망에서부터 휴대폰 통신망인 롱텀 에볼루션 5G까지 이용해서 드론의 통신 거리를 무제한으로 바꾸어 장거리 임무 수행이 가능하게 되었습니다.
In these civilian systems, the most important thing is wireless networks. Long-distance missions can be carried out by changing the drone's communication distance to a limited distance using dedicated network to LTE and 5G.
비행 제어 및 내비게이션 시스템은 고도, 저전력, 데이터 링크 장애, 비행시간, GPS 장애, 무선거리 문제 등을 한꺼번에 해결하는 데 목표를 두고 있습니다.
The flight control and navigation system aim to address altitude, low power, data link failures, flight time, GPS failures, and radio distance problems altogether.
새로운 비행 시스템은 고신뢰, 고성능, 군사용 등급의 비행 시스템이어야 합니다.
The new generative flight system should be high reliability, high performance, and military-grade flight systems.
캔버스 통신을 통해 내부 통신 규격을 통일하는 것이 가장 중요하다고 말씀을 드리고 싶습니다.
I'd like to say it is recommended that internal communication standards should be unified through canvas communications.
새로운 드론 시스템은 폴리머로 외부 코팅을 하고 내부는 카본 파이버로 경량화하는 데 목표를 두고 있습니다.
The structural part of the new drone system is outer coated carbon fiber with polymer, which can be used to reduce weight and stiffness by using a variety of the composite materials.
화면은 자사 기준으로 어떻게 제품의 성능과 품질을 개선했는지 화면을 통해서 보여주고 있습니다.
You can see at the screen we will how to improve the performance and quality of our product based on our own standard.
감사합니다.
Thank you.
Thank you, Seiji. Okay, we have a good 15 minutes to further the discussion, which is good. There is a technical aspect I wanted maybe to start with because it's been barely touched during your presentation. It's the question of security and fail-safe for the drone, the drone platform. How do you, maybe we can do a quick turn on the table, how do you address the failures that are, that will inevitably happen? You want to start?
Thank you very much for sharing. So, I think I think we have to look at failures that they are not only bad, because you can learn a lot. So during the time since we started, of course, we had lots of learnings. For example, like
software bugs and then like some component fails. And I think this is the critical thing, and I see this with all of us here, like having 4 rotors is always a bit critical, especially in hovering. So that's still something to, yeah, not even a parachute can really help. So this is some tricky things we still have to solve. I mean, generally, okay, if failures happens, you normally do incidents report, whatever, and so on and so forth. But I think your question is more about what can we do to tackle, like to even avoid any losing a system or even
indeed, or mitigation of fail-safe systems in order to minimize the impact of failure during the flight, maybe.
Yeah. So, I mean, we are looking at the hardware and at the software and taking all our learnings now into consideration. And I can speak for Wingcop at least that we are now, we have learned a lot, enough also. We know everything about our platform so far, and there will be next generation we are now working on, which includes like redundancy, basically the main issue in software and hardware, which then again will lead to a very easy to use and much more reliable operation. Yeah. So yeah, we thought about this for the last years actually, and yeah, now we are working on this big step because that's actually something what you like. This is the main thing in the UAV industry. I think everyone experiences once in a while some pushback, and yeah, we should share it more in this industry. I think this is something like sitting here, like we are having all kind of similar systems. The history behind why they are similar is also interesting, but let's look at the learnings we all have, and if we could share once we learn something, it would be maybe faster to recover from pushbacks, and we all could help to make a much more reliable and safe industry. But yeah, this is just I leave it up to my colleague now.
That's a good point. That we don't talk about our failure too much. We do experience them quite a lot. I had my share, certainly. Juan, you wanted to say something?
Yeah, I wanted to add that I think that there's no general formula for any kind of operations because, as Tom said, like for instance, a zipline is using parachutes. In our case, we were studying like power lines, and I don't want to shoot the parachute and let it go against the power line, so it's even worse. So in our case, we went for the VTOL because of that, and also because you have this extra reliability with the redundancy of the VTOL system. So I think that it's depending on the use case, like you should go for one or other strategies.
That's a good point.
So I would like to clarify a bit between security and safety. So security, that means like on the software side, which is this kind of stuff. For Phoenix Wings, since we have developed all our software ourselves, we are in good position to actually tackle those problems and to do something about them. On the safety side, we already have now partly redundant systems, and we want to later move further in this direction. And there's a lot of regulatory action happening, and we as a company would also like to participate, like we talked already with others, in these boards, how to make certification happen for the unmanned aerial sector.
I think I talked also a little bit about security. I was hesitating a little bit by connecting the plane to the internet, so our plane, but yeah, then we had to do that. So I think I tried to learn from a lot of mistakes I heard from other industries that connected their machines to the internet, and then some hackers, researchers came and easily broke their system. And I hope I learned from them, and I hope it's not so easy to hack into our drone here. When we're flying here, we are using, we have a VPN, and the telemetry is encrypted as told. And I hope I didn't make any beginner mistakes while implementing the IS encryption. And yeah, that's on the security side. On the safety side, of course, being a small UAV and being VTOL, which is carries a lot of extra weight when it's flying, and it's not really, it's a compromise in both. So adding redundancy is really hard. You lose a lot of payload capacity or range. So we cannot, at this point, we cannot really afford to put in 8 motors or something for hovering. So we have only 4, and but we try to, we designed the system, so we learned a lot. I built a lot of planes and learned from several crashes or near misses, and we try to reduce the numbers of cables, of connections, and what we have inside to be like as reliable as possible. We can make by not increasing the cost so much of production, and to have all the big overhead that you have for manned aircraft. So we try to also mitigate it by operation. So only hover next close to the takeoff point where there should nobody be around. So if a motor fails, it will just fall down there and just destroy the drone, but nothing else. And when flying fixed wing, of course, we have some redundancy. It can also fly with one aileron, for example. But of course, adding more, maybe other controls and making them redundant could be an option. We have this commercial or known Cube autopilot, which has 3 IMUs. Currently, only one GPS, so this could fail. For the Lake QV challenge, we thought about some contingencies while having the remote pilot on both sides, so it should always have connection, and then using the compass to just try to continue flying manually in an altitude hold position, which works with internal barometers. So we hope in this case we have enough contingency plan to bring the drone safely back home. Otherwise, it would probably, if something really fails from experience, it will just fall down in the water and then harm nobody else. But we hope this will not happen.
And Seijin, in your drone, do you have any fail-safe mechanism?
This mechanism?
Fail-safe, like
security. I speak for security. Business drone and industry drone must be security module, because sometimes someone attacked RF spoofing or RF hacking and jamming, drone data link broken. Data link broken is a very big problem. If I don't communications ground stations, drone fall down on the ground. This is a big point. Almost drone needs security code hardware or software based on system needs. Pushers, anti-hacking system is safety is just all drones need security hardware or software need. Sorry.
I guess security is important. I was getting at fail-safe systems as well, which is clearly which are clearly two different things. I guess what I'm getting at is back to the cost questions that we discussed before. There is no point removing 5,000 euro from the cost of the system if it's gonna crash more often, or if it's gonna crash at all, because a drone that crash is worth nothing. So in the spirit of demonstrating reliability of the drone and convincing customers, such as the speakers we had before, what are your actions? I'm pretty sure it's work in progress still, but how can you convince your customers that the drone you will pay, I suppose, several thousands of euro upfront, is going to last for the 5 years and thousands or maybe even tens of thousands of flights that are needed in order for your customer's business case to hold? anyone want to address something? Is that a challenge? How do you address this challenge?
Should I start again?
Sure.
It's like, okay. So, I would say, taking it to a more higher level, it's looking at the whole industry. We are all pioneers. I think even the customers. I'm actually very happy that we get lots of inbound requests, lots of great ideas, interesting projects I never thought of, like measuring perma gas or the gas in the Arctic because of climate change. So really, really interesting projects and people coming up with great ideas. But still, everyone here is really pioneering. So I think what counts to giving trust in a system is if you need to think about maintenance, you need to think about customer service, and also since especially like basically most of our customers are quite our friends, and we are in very close communication. So that's very important to listen to the feedback. Also to be there when something is needed to quickly move out. So even if it's in the Arctic, we were helping our client to set it up. So we were going to extreme situations like minus 40 degree. We equipped the drone. We customized a lot actually. So this is also giving some good confidence. So right now, every project basically is somehow a customization. So for example, working in the Arctic, we needed to make the drone work at minus 40. So the batteries needed some heating system inside. We needed to change the iron components to carbon fiber components so they don't get stuck, especially since we have tilting rotors. It would be a problem if they stuck in between. So actually wouldn't be a problem. 45 degrees is also fine. You can still fly since the configuration it's always a multicopter, but yeah, you want to have it fully working. So yeah, it's a lot of like listening to the customer, customization to the point where the customer can really use it, and then helping whenever help is needed. Staying in a very close relationship. Best thing would be if you are like friends, so you get really honest feedback, and then you can improve. And I think again we are pioneering. So even every pushback we get in a project, I'm lucky. Like every customer we have, even there, of course, I think no UAV manufacturer has never had a. So everyone has once in a while a fail. No one can tell me the drone is 100% reliable, we had never an accident. No one. So I would say even if this happens, the only most important thing is that you stay in this good touch, you learn, and then you improve your system. And this is actually what I said before in the question. So for example, you asked for reliability. We are now looking at different kind of sense and avoid solutions. There are some great startups out there who are working on this. So we are implementing, for example, Cassia is something we are looking at, yeah. And there are many other options. Iris Automation is one of the startups, but there are more. And then this is sense and avoid, and then there are other nice startups working on what happens if the GPS gets lost. We tested a solution. It's unfortunately quite heavy. You need to, the more sensors you add, the more heavier the system gets. I think my colleague here from German Drone said the same. So if you add too much stuff to make it super reliable, you can't even take off anymore. You cannot have any payload below, which then means you have no solution to the application. But yeah, so we solved it with customization and being very close to the customer.
Yeah, sure. But then it's a chicken and egg problem as well, because even when you did your engineering homework, if the customer wants to buy a plane that will sustain 10,000 flights, at some point you need to demonstrate those 10,000 flights,
sure.
or something that's reasonable. Maybe the other, you wanted to add something about that?
Just one quick thing. So yeah, you can do this at the beginning as everyone is pioneering. You can customize a lot. You can be close to the customer. At some point you need to have a system which can be sold like once after the other, and you cannot always run after every customer. If you have 10,000, it's going to be a problem. So we took lots of learning in. Now the next generation of the Wingcopter will be a copter which you can just plug, play, and use, and you don't need to ask us all the time about like, can we work out a project together? So yeah, it's learning and then improving the system to a point where you can mass produce and then use it like any other tool you should use on your own, solving your application.
Wanted to ask something?
Yeah, I think that we can have like two approaches. One from the business side. I think, as I said before, like you can rent the drone instead of putting all the risk on the customer or the operator, and even do like our approach is doing the first proof of concept together so that you can have the learning and training and so on, and then you start operating on your own. And from the other side, from the technical side, I think that we can do two things. One is providing more data, like reliability test, not only about the aircraft, but from the components. Like, for instance, some of the servos have reliability tests, so you can provide more feedback on that. And also, I think it's not only about the components, because some of the things that we are doing, like all of us, or most of us are doing carbon fiber parts, and I don't think that none of us has tried like to reach the limit of the fatigue of the carbon fiber parts, like 10,000 flights. I know, at least we didn't. So there's some kind of uncertainty, and then you can put all the responsibility on the customers, because it's like you never know. And as Tom said, if we are pioneers, like, we cannot take for granted that some things will never fail. So that's more or less our approach.
I think it makes sense. Sven, you want to add something?
I guess I have to say I agree with my two fellow speakers here. It's about building a proven track record, and on the way to that, you have to work with the customer and do it in conjunction. And I mean, there are many different projects out there, and I guess everyone here is currently figuring out what will the models look like, what business are you going into, and there are many challenges that you can only solve with the customer together.
I assume offering warranty, full warranty for the customers is standard practice among the manufacturer, or would someone disagree with that?
Yeah, of course, guarantee you have to buy in Germany or Europe. Of course, you have to, I think, 1 or 2 years. Yeah, I mean, I have some experience before from like more traditional industry and like automation stuff. We also had, or my father had, still has a small company. We were building like special machines, and I mean, there are a lot of small companies building special machines, but they can rely on a huge supply chain of proven components, like of your PLC, of your components, cables, pneumatic cylinders, and all that stuff. You know, if you buy that from that known brand, it will last. I did this well, and after 10 years, a customer called in, we need some replacement, but this was after 10 years, and then we came there and we saw a belt was like worn down and just had to replace some motors and some gears and stuff. And then I looked at the control panel, and it had like 24 million parts done. So I was pretty proud of that. But yeah, we are not there yet, I think, in the UAV industry, but I think we're getting there, getting more away from the model airplane parts, maybe getting more professional done, servos and motor controllers, motors, propellers, and all these things. So I think the whole industry will get more reliable, since there will be a supply chain that supplies more reliable parts to be used. Also, I mean, open source software helps, I guess, which got a lot better. Yeah, and maybe also that's I think that not one manufacturer can prove so many flights, but you can maybe then from a supplier that can say, oh, I sold it to this many companies and they all tested it, and then you can customize your drone from these parts, components, and then I mean mechanical stuff. Maybe you have to still have your own design, but I think there's a lot of knowledge on how to build airplanes reliable that they last that long. So I guess it's more on the electronics side that which are new for the unmanned, because you need a lot of software and stuff.
Yeah. Okay, thank you. That's a very interesting point. We are now eating into the break, which is a kind of common practice, but we'll try to minimize it. Before we close this session, maybe we take a few questions from the floor. Anyone? There is one question here.
Hi guys. One question, I see that there are two different approaches to what you're doing. There are the guys who are basing their softwares on open source hardware and building on top of it. and there are guys who are developing everything from scratch. So my first question is, are you even developing the hardware of the autopilot control system for the guys who are doing it? And my second question for those guys is, how can you compete with the others who are building on top? And the question for the guys who are building on top of open source is, how can you make sure you mitigate all the risks of open source? So we're talking here about the cube, I think for everybody. And for example, July of last year, there was a critical bug in the VTOL firmware of the cube, which made the VTOL transition even at 1 meter if we had a failsafe, which is improbable, but a risk to take into account. So how do you mitigate this risk?
Let me jump right in there. So don't get me wrong, I'm a huge fan of open source software. I just think for the special needs and our goals we want to develop, we just have to do that our own. And this will show later. You can quickly get a drone up and running with open source software. But down the road, with the goals we have, especially into maybe fleets or stuff like that, you will run into certain barriers. And then it will show that you have invested the time to do it yourself and benefit from this investment.
Well, we are also using open source autopilots, and it's not that we are like a fan of something, it's that we tried both. We bought a commercial flight controller, I will not say the brand, and we were not as happy as with open source. I think it's basically because there are a lot of platforms using open source software, so they are iterating easier and faster all the bugs in the software, while if you are buying a commercial flight, it's like, as they said before, like you have a limited number of units using that. So in our experience, it's better because of that. I think also because in our case, the added value of the system is not the flight controller. So then you can get the best software, but if you cannot develop something that is useful for the end customer, what's the point of, in our experience, doing everything on your own? We cannot be good at everything at the same time.
If you want to add something.
Yeah, I think it's a little bit the question of focus. Especially as a startup, it's always hard, as long as you don't have the luck to be close to maybe a big group of venture capitalists, like sitting in maybe San Francisco or Silicon Valley. If you're in Germany, for example, yeah, let's take our example, it's very hard to find any funding for especially hardware. Software is easier to scale. I'm not talking about drone software, I'm talking about software startups. So it's very hard to raise any funds, and then you have to really think, will you build up a whole software department at the first step, or will you concentrate on the aerodynamics and everything, especially also when your team is more skilled in that hardware stuff. But also, I see your point. It's going to be like now, since the industry grows more matured, or will become, or needs to become much more solid, and at the end, the strongest and most reliable systems will win, and also it's about certification at some point. It was a bit of Wild West feeling. I don't know how to say that in English, but it was a bit like model aircraft building, and let's just let it run, and we test a lot of stuff. And now it's about serious applications, about huge fleets in future, thousands of drones hopefully, solving lots of problems in the world, and that's when no one wants to see heavy crashes of like a full fleet. And that's when we need to think of, okay, how can we have software which can be fully fitting to all the certifications, which are just being made up, so it's also something. Now the rules are coming. So yeah, so I think it was very great for us, for example, to start with all that open source software. We could be really fast without spending millions of euros into a software department. But at some point you need to ask yourself, like, is this all the way the right thing to do? And yeah, as I said, we have lots of interesting feedback and learnings, and now we know what to do next, and we're going to do some things different. And also in software, we looked at what can we do much better, maybe on our own as well, and looking for the right people. Yeah, so anyone, if someone is here in software, yeah, it would be nice to talk.
Thank you. Any other question in the audience? There is a question back there.
Hi, Paul Georgie from GeoGeo, a mapping development company in Scotland. Let's just assume everything's safe, everything's reliable. You've all sold several thousand units across the continent of Sub-Sahara. Now, much like our operations in Scotland and in rural Sub-Sahara, there's one thing that would concern me. I challenge you to see which one of your softwares actually begins to integrate that. And that is, of course, the Category 1 endangered species of birds. Now, that is prohibitive in many months of the year, where simply having robots, flying robots overhead can be very disturbing to their breeding patterns. In many areas of Scotland and Ghana, even here in Rwanda with a certain white-backed vulture, there are Category 1 endangered species of vultures. So given that these data sets are currently being harmonized by other agencies from around the world and the international community, I guess the challenge would be, is that something you would consider to start adding more environmental data into the software? Because as a drone user, it's certainly something that is a huge challenge in terms of our operations and regulators.
Let me jump there in. As a model hobbyist and model flyer, it's quite known to us in Germany that actually this can work quite well between aircraft, little aircraft flying and birds flying. Actually, birds are tending to be known to actually search the places of model flying fields. They're used to that, and there's not much else around. It's mostly remote places, so I don't think like there will be some transition phase, but I think in many cases we can argue that they might get used to that. Of course, planning the flight routes should also include certain environmental protection areas. We are already like, there are several factors in it. This is one of it, but there's also like noise pollution, also for the general population. And we are already participating in projects that are about modeling the noise impact, for example, on flight routes. And you would start planning routes according not only to aviation safety, but also to other environmental factors.
Yeah, that's a very good point. Is there any other question in the audience? One question over there. Can we have the mic?
How much do your drones cost?
I didn't dare to ask that question myself because, from experience, I don't like being asked. But now that it's done, anyone willing to answer?
In our case, it's a fixed cost per kilometer. So take the cost of a helicopter, and it will be lower than that. So depending on the application, we can talk.
Anyone?
Yeah, I think the problem is mentioning I had this before, so mentioning a price, for example, to the press, it's going to be stuck there in the mind, and everyone is, I think the main challenge of the UAV industry is getting now drone operations feasible, right? So everyone was happy that now we can solve the last mile issues faster. The next big question is how can we do it cheaper than anyone else, because then that's when it scales. So I think this is the problem. If we mention a price now, you will all know that, and then, oh, that might be. And of course, drones are these days quite expensive still. We need to also buy lots of components, and then we have to integrate them, and lots of time and whatever, and then it ends up with a price which is not maybe feasible to bring here 1,000 drones to solve like a full logistics solution in Rwanda today. But that's something we work on. So what I could answer, I would also hesitate to give the price, because also we do a lot of customization that adds up to the price as well. So if you need like a drone in the Arctic, it's different than you just need the drone we have right there. So, but what I can say is that I think, and this is probably the goal of everyone here, is like looking at the supply chain, how can we manufacture more? So this is also a big question in the industry, how can we ramp up? You will find lots of companies right now that can build you 2, 3, 4, 5 drones in a few weeks or maybe months or whatever, but you ask someone to build 10,000 in 2 months, and that's going to be challenging. So this is like, how do we ramp up mass production? And then by doing so, maybe automation is also a topic we should think of in this industry right now. It's not totally possible, especially with glass and carbon fiber stuff. It's still lots of handwork, but I can say that this is the big challenge, to bring down the cost of the full unit or of the miles you fly or whatever model you have, whatever model you sell, if it's subscription or if it's pure hardware sales. Yeah, but we are all facing this. So mentioning price is just risky to the future of all of us, because everyone wants to bring this price down, that at some point it's going to be the solution for everyone. Yeah.
Let me maybe also bring this question back to you. Let's say like that, I have said this to many people already on our booth. What we as drone manufacturers here would be all interested in is like what would be the good you want to transport and what can be the price for that. Because like the price per flight where you can make a business out of it is driving the design of the aircraft. So if you fly a super big sensor that's super expensive, you will design a different drone than if you need to just bring some small blood bags, for example, or something else that is a very compact payload, and you have a high volume on small parts. Then this drone will look very differently. So it's not so easy to answer. That everyone is reluctant to do so.
Well, I think a break is much needed to pursue the discussion and go into the details. I think we will leave it at that. The plenary sessions will resume in 15 minutes in this room. Till then, there is a tea break as usual. I would like to thank the speaker again and give them a round of applause.